Hello everyone. We're going to continue doing the Logic Gate review for your test. Some of you pointed out that we don't have school Friday. So obviously, as you can see, the test is moved to Monday. So that means basically this week we'll just work on reviewing, and then Monday you'll have your test. Okay, so that'll be all you have to do Monday, and it'll be due the same day. So I would suggest getting started on it early. Okay, so we reviewed the how to draw the circuit symbols and truth tables for AND or NOT gates. So today we're going to look at waveforms and Boolean expressions. Okay, so for the AND gate, this in green, so I know I showed you this before, but this is the expression I want you to get used to using. Okay, at least for now. As far as any type of Boolean expression, it's just going to be the multiplication for AND gate. For an OR gate, we're going to use the plus symbol. Okay, so not this one. If you go to college and if you have to take any extra maths, like elective maths, there is a math called sets and logic. And basically you don't deal with logic gates, but it's basically just using logic math, so Boolean algebra. That's basically all the class is. So these are pretty easy, and if you need an easy math elective, look for sets and logic. Okay, but yeah, so that's kind of what you would use in the math class. As far as physics goes, we're going to use these. Okay, and the NOT gate, remember, was just a line. I have it back here. The NOT gate was just a line over it. Okay. For the waveforms, so this one's already done. So waveforms is just that. So you have on and off for each input, and then you just have to match the output based on whatever type of gate it is. So OR gate means either X or Y has to be on. Okay, so on the dotted lines is basically where you're taking like the reading or where it might change. So this does not count as a certain type. So it switches on here. So don't think that it's off and on. It actually switches to the on here. So now from here to here to here, all this is considered on. There was a couple questions about these spots where it changes. Okay, so you cannot consider this both off and on. Okay, it's whatever it changes to. So it's on here. Here this is considered off, just like this is considered on. Okay, so for the output for an OR gate, as long as one of them is on, the output's on. Okay, here they're both off. That's why this is off. Here this switches on. That's why this one changes. Okay, so you went over this one, so I wanted to review that one. You had to draw the output waveform for a 3-input OR gate. So as long as A, B, or C is on, then the output's on. Here they're all off, so this is off. Off, off, A switches on, so the output will switch on. So in this time frame, A is on, and this time frame B is on, and in this time frame C is on. So from here to the end, at least one of the inputs is on, so the output will be on for the rest of the time. Okay. And for the AND gate, same idea, except that it's an AND gate, so X and Y both have to be on at the same time. So basically anywhere X and Y is not on at the same time, the output is off. In this case, there was no instance where X and Y was on at the same time. So the output was completely off. It never came on. And here's some more Boolean expressions that I showed you. So no matter how many inputs you have, you just write it all as one multiplication type expression. Okay, so that's pretty much it. So hopefully waveforms and the Boolean expressions are pretty clear. Hopefully everybody understood waveforms. Everybody did good on the assignments, so I'm assuming there's no additional questions, but if there are, just message me with Teams, and then tomorrow we'll start looking at some more combination type problems. Alright guys, have a good day.